Well, thanks very much for the opportunity to give this presentation. I'm going to give you an update about the RUSALCA program. That stands for Russian American Long-Term Census of the Arctic. And on my title slide here, you can see an outline of what I'd like to tell you about today. I'll start with a brief review of the origin of RUSALCA. It's such a unique program. And then I'm going to tell you about some of the highlights that we have from our first decade of science. And then I'm going to talk at the end about our next phase. We're just entering the next phase of RUSALCA starting this summer. It's a 5-year phase, but I'm going to really focus on the field work for the 2016, the first year of our new phase. By the way, if people have questions, just please interrupt me, and I'll be happy to answer. All right, next slide. So let me say some words about RUSALCA's origin. Next slide. So the groundwork for RUSALCA was really done back in 2003 when NOAA and the Russian Academy of Sciences signed a memorandum of understanding associated with the World Oceans and Polar Region Studies. And so this really enabled a program like RUSALCA to start. Next slide, please. The original goals, I have them listed here, and they were really quite wide-ranging, from collecting observations in this region where we know the sea ice has been vanishing very quickly, particularly in the Pacific Arctic. We wanted to measure various fluxes, volume, freshwater, heat, learn about the pathways, monitor the ecosystem indicators of climate change, model and forecast possible changes in the future. And then 5 and 6, I think, were also very important to improve Russian-U.S. Arctic science relations and explore the unknown Arctic. So those were the original set of goals for RUSALCA. Next slide. So back in the early 2000s, there were really no programs that were taking ships into the Russian part of the Arctic, and for U.S. scientists. And I know that many programs were trying. I was part of the SBI program, and we were trying to get clearance to go into Russian waters, and we were not able to do that. And I think the one unique aspect of RUSALCA that made this happen was that we relied on a private-public partnership. So you see in this slide here, we employed a company called Group Alliance to sort of act as the go-between between the Russian agencies and the U.S. agencies. And this Group Alliance was, able to negotiate the Russian system more effectively and enable things to happen, which I think some other ways forward might not have allowed that to happen. So this unique relationship, I think, or unique setup, allowed us to actually make this happen, to gain access into Russian waters. And we were the first group in a long time to be able to do that. Okay, next slide. There are a lot of entities from the Russian side that are involved with the RUSALCA program. So you see on the left, the Russian Academy of Sciences has a number of institutions, including Shirshov, Rosh Hydromet, including the Arctic-Antarctic Research Institute. And then on the right, you can see there's various ministries that are involved. So a lot of different Russian government partners. Also important to say that there was a large contingent of Russian scientists involved in the program. And that was one of the goals of RUSALCA, to bring together the scientific communities from the two sides to work together, both for collecting fieldwork and also for the analysis. And I think we've been successful with that. Okay, next slide. So that's a little bit about the origin of RUSALCA. Now I'd like to tell you some highlights about the first decade of measurements that we had. Next slide. So the original domain of interest was the Chukchi Sea, which you see in front of you here. This, of course, is the Pacific Arctic gateway. All of the Pacific water entering the Arctic Ocean goes through Bering Strait and has to navigate its way across the Chukchi Sea. And the Chukchi Sea, it's very wide, it's shallow, but it has some very interesting topographic features that really impacts how the water moves and various different aspects of how the physical drivers affect the ecosystem. I've listed a couple of the features here. There are 2 shoals, Harold Shoal, Hannah Shoal, and there's 2 canyons that cut into the shelf, Harold Canyon on the west and Barrow Canyon on the east. So there's the topography of the Chukchi Sea. One very notable thing about the Chukchi Sea, if you go to the next slide, is the fact that it's divided roughly in half by the U.S.-Russian convention line. And of course, that means that the sampling has been very biased over the decades in terms of what the coverage is. And if you go to the next slide, I really like showing this slide because this shows you the station coverage from two of the major programs in the first decade of the 2000s, the SBI program and the IceCape program. And you can see the coverage is just phenomenal on the eastern side of the Chukchi, and absolutely nothing on the western side. And if I were to throw in all the programs that have happened, particularly over the last 5 years or so, I think we'd start to turn the right side of that plot just a shade of black because there's so many measurements, and yet we would still have this dearth of observations on the western side. So that sort of gives you an idea of how important it was for us to start taking measurements in the western Chukchi. So next slide. Of course, this is a figure showing streamlines, flow water pathways, or the white thin lines. And even though there's a geopolitical boundary in the center of the sea, of course the water doesn't care about that. And you can see that there's about a third of the streamlines, or a third of the water, heads over towards Harold Canyon, and of course there's lots of ramifications in terms of ice melt and nutrient transport and habitats for whales, whatever, that doesn't care about that geopolitical boundary. So again, important to try to measure the entire Chukchi Sea if and when we can. Okay, next slide. So Razalka had two components, a mooring component and a shipboard component. And here I've shown you the three broad-scale surveys that Razalka did in its first decade: August 2004, September 2009, September 2012. And starting with August 2004, we sort of had a couple of goals. One was to measure the southern Chukchi Sea, where a lot of the biological activity is enhanced there. And also we wanted to do some exploring. That was one of the original goals that I mentioned earlier, explore unknown areas of the Arctic. So we decided to focus in on this really important dynamical choke point of Harold Canyon. And we did a set of survey lines that were very high resolution. That was the first time that such a survey was done in that canyon. So that's what we did in 2004. And then in 2009, we had a little more ship time. So we expanded the coverage. I don't know if you guys can, if you can see my cursor here. We did some work around Wrangel Island. And then in 2012, we had similar aims, but we ran into weather and ice, and we were much more limited in our coverage. So those are the station locations of the three broad-scale surveys. If you go to the next slide, I like to point out that there was another joint venture. This was between Russia and Sweden in 2008, and they actually repeated some of our Razalka lines. So in some sense, we actually have four broad-scale surveys. I thought that was really neat to see that another nation was following what we had done. And we're in the process of just now. We have submitted our first publication that uses data from all four surveys. Okay, next slide. The other component of Razalka is moorings. So here you're seeing the set of moorings that were across Bering Strait. From the U.S. side, this is now part of the Aeon program, and on the western side it was Razalka. So you can see in its full coverage, we had 8 moorings in the strait, 3 of them on the Russian side, and we had them there for 7 years, from 2005 to 2012. And then we had a 2-year hiatus, and now since 2014, we have one of those moorings on the western side. And I'll tell you a little bit more about that going forward in just a few minutes. Okay, that's the mooring coverage. A diverse set of multidisciplinary observations. Next slide. And then the next slide, I'm going to show you an example of what I mean by that. So here is the station coverage for the Razalka 2009 cruise. And the red crosses are the CTD stations with dissolved organic carbon and nutrients. I'd also like to point out that up here we took some measurements way to the north, up near the ice edge. So that's the basic, physical, chemical coverage. And then we had lots of other things like zooplankton tows. Next slide. And the next slide, fish trawls in the blue dots. And then next slide, bottom grabs in the cyan dots. Next slide, primary productivity in the black dots, black squares. Next slide, sediment cores. Those are the green squares. And finally, next slide, ROV sites to get a better look at the bottom. So a very diverse set of observations as part of the program. Next slide. So a lot of science has come out of this. We've had 2 special issues. One in January 2010 was deep sea research. And just last fall, we had a issue of oceanography dedicated to Razalka. You see the cover of it there on the right. Next slide. This is just a short sampling of some of the nice articles that we had in this oceanography special issue. And I want to point out that, you know, all of these articles, not only are they interdisciplinary, but I think every one of them has joint co-authorship between Russian and U.S. scientists. And that was, I think, one of the biggest highlights that I can say about the RUSALCA program, you know, that we had this two communities of scientists working with each other, not only to do the field work and collect the observations, but actually to do the scientific analysis and bring it forth to the publication stage. Okay, next slide. So, all right, so that's what I wanted to say in terms of brief highlights of the first decade of RUSALCA. And now I'd like to spend the rest of my time talking about the next phase, and in particular, I'm going to focus on the plan for 2016, this summer. Next slide. So the goals are pretty much the same, although I do want to say that we're in the process of still trying to flesh out some of these things as we get started into the next phase. But we still want to do some basic things like, you know, measure the various fluxes and the transport pathways, you know, monitor ecosystem indicators, do some forecasting when possible. But we still, importantly, number 4, we still have explore new areas and phenomena in the Arctic because, you know, as I think I've made abundantly clear here, we still have lots of holes and lots of things to discover about the western side of the Chukchi Sea going into the East Siberian Sea. Next slide. Okay, so let me say a few words about each of these. Number 1, talking about the fluxes of various quantities. Next slide. So we do have this mooring that's still on the western side of the Bering Strait, mooring A12 over there in the west. And now you'll notice that there's a reduced set of moorings on the eastern side. So this is what the present configuration of the Bering Strait Aeon array is. So there's 3 moorings. And I do want to point out that mooring A3 up to the north there, right next to the convention line, Rebecca Woodgate, the PI of that Aeon program, is fond of saying that that's capturing what's coming through the western side, and it does capture some of the water and fluxes that come through the western side, but it doesn't do it all. And we know that from RUSALCA now. We know from what we've done over there in Harrow Canyon and comparing it to what's coming through Bering Strait, we know that you need to have information really on the western side of that strait to understand the connection between what's getting fluxed into the strait and the response that's happening downstream. So it's really important to have this mooring going forward on the western side of Bering Strait. Okay, next slide. Number 2, monitoring the ecosystem indicators with a mind towards forecasting. Next slide. Importantly, RUSALCA is tied very closely with the Distributed Biological Observatory Program, DBO. I think you probably all know about DBO. It's this great program where, as a community, we've decided to monitor different locations as you go from south in the Bering Sea all the way up now into the Canada Basin. At these locations, we've defined hotspots. And the idea is that as different nations take their icebreakers through Bering Strait into the Arctic Ocean, if they have the time and the inclination, the interest, then they stop at 1, 2, or however many locations of the DBO sites, and they take a suite of measurements. You know, whether it be a simple CTD section or whether they, you know, get into more of, you know, chemistry, biology, sediments, whatever. But by having this happen, we start to collect information from, you know, the locus of all these cruises that are going through. And it really seems to be working, and I'd like to go to the next slide here. This shows you the number of CTD crossings in the DBO lines going forward from when it began in 2010 as a pilot program to where it was as of last year. And you can see, you know, last year we had almost 30 CTD sections done as part of the DBO program. And I think that's brilliant because, you know, this wouldn't have happened unless the community was talking to each other and coordinating itself into doing this. So we have this, this program in place. And next slide, please. Here is the tentative station plan for the Razalka cruise in 2016. Those are the black dots. And the first thing I'll point out is that 2 of those sections are, in fact, DBO lines, DBO3 and DBO4. So we are part of this monitoring process. Importantly, you know, of course, with the Razalka lines, they go all the way west, you know, over to the Siberian coast. You know, at here in DBO3, and also in DBO4, we go over to Wrangel Island. Just as an aside, this particular line, the DBO4 line, is positioned to capture what we think are the major pathways. And this is a bit exploratory. You know, we think some of this water that comes from Bering Strait up towards Harold Canyon gets shunted off and heads over here. And so this set of lines will capture everything going north and will give some more information about the division of this water through various parts of the strait. And this is important for lots of reasons, including the fact that, you know, these pathways are carrying high nutrient water in certain times of the year. Okay, next slide. Again, in terms of monitoring, we are repeating some of our own lines that we've done in the first decade, those that you see circled there, so that you know, adds to the time series that we have going forward. Next slide. I talked earlier about the moorings. We will have the mooring in Bering Strait going forward, and we hope to have a mooring in Harold Canyon in the future. JAMS Tech has agreed to fund that mooring and join the Razalka program. We tried to get it set up for this summer, didn't quite have enough time, so but there's no showstoppers, and we think it's going to happen starting next year. Next slide. All right, and the last part, this explore new areas and phenomena in the Arctic. Next slide. I think you also probably all know about the Pacific Arctic group. You know, the 6 nations that work up here in the Pacific Arctic. We have a couple of meetings every year. We discuss and share amongst ourselves, you know, what each nation is doing, and importantly, we try to coordinate, you know, whether it be sharing berth space or actually trying to you know, collaborate and get something that, you know, you wouldn't have gotten by having just all these individual efforts. You know, the DBO program was largely influenced by the PAG group. Okay, next slide. So here's an example of, okay, we meet and each nation talks about what they're going to do. Here were the 2015 activities of COPRI, and there was a lot of coordination in recent years to start focusing on the borderlands, the Chukchi borderlands, which you see there. That's where most of their stations are. But I want to point out, you know, again, down in here, you know, this is a really important part that these nations can't get to. And if you go to the next slide, you can see that sort of motivated 2 of our Razalka lines that are in the East Siberian Sea, crossing from the shelf into the slope. And these are important lines because, for instance, if you think about the water, the Pacific water that comes out here through Harold Canyon and out this way, it's meeting it's, you know, emptying out into the open Arctic right there. And of course, you have Atlantic water that's come all the way from Fram Strait or the Barents Sea, and it's worked its way all around the Arctic, and it's coming in a boundary current like this. So this area is the first place where you actually have the meeting between the Atlantic water and the Pacific water, and they're just order 1 questions that we don't know about. For instance, we don't even know if there's a boundary current here, over here. So, and we think that there's a, you know, potential nutrient source here in the East Siberian Sea. You know, what is it? How does it communicate? What's the shelf basin exchange process? So, again, exploratory, very basic questions, and that we want to still try to do that in the Razalka program. All right, next slide. Let me just give you a couple of particulars about the field work. We still haven't finalized our vessel. We're looking at the Victor Bonitsky that you see here, and you can see the various parameters of the ship. I do want to point out at the bottom, the science accommodation, it's 20. That's a little bit less than we would hope for. So we have to be, you know, that's going to limit us a little bit in terms of the amount of components we can do and the number of people we can bring. But, you know, we'll try to work on that going forward to see if we can get more people and a different vessel. Next slide, please. Another important aspect here is the instrumentation. As it may not surprise you to know, or maybe you've experienced it yourself, it's very difficult to in terms of customs and shipping and expenses to ship stuff over to Russia, or even to Nome to join a Russian ship, and you got to deal with Coast Guard customs, Coast Guard regulations, etc. So what we've decided to do to get around a lot of that is to purchase fabricated instrumentation and have it reside permanently in Russia, and then just use the Russian vessel to and from the Russian port. And that way it's going to be a lot simpler and much less complicated, and ultimately more reliable. So we've done that with all the mooring components. We have the mooring that's deployed already. And what we're going to try to do for this summer, or we are in the process of doing, is fabricating a CTD system. We're calling it the RUSALCA rosette system and winch. And the picture on the left is what it should look like when it's fabricated, something like this, a very compact CTD system, but fully operational. It's Seabird 25, 12 5-liter bottles, upward, downward facing ADCP. And we hope going forward to get more biochemical sensors on there, but that's what we have for the first year. And importantly, on the right here, we have purchased a winch, or in the process of purchasing a winch with conducting wire. And why that's important is because, there's a lot of uncertainty about the vessels. There's also uncertainty about the capability of the vessels, whether their winch even works. So this way, regardless of the vessel, we are sort of self-contained here by bringing our own winch and CTD system. And we have conducting wire, so if the ship can handle conducting that wire, that's great. If the ship can't handle that, then we can use this thing in self-contained mode. So no matter what the circumstance, we can still take our measurements. So that's what we're sort of looking for in terms of instrumentation going forward. Next slide. So the parameters measured on the 2016 cruise, this is what we're looking at. So you can read these as well as me. Physical, chemical, biological, benthos, upper trophic, and geological. So we're trying to, again, realizing we're on a smaller ship, we're still doing a broad array of measurements. And lastly, the tentative plan is to have a 20-day cruise starting around September 10th. And one thing we want to do going forward is we want to try to do these cruises at the same time each year. And as you know, Jeremy Mathis is now the new leadership of the program, new program manager, and his vision is to try to have a yearly cruise for the next 5 years. And so we're going to try to make sure that these happen at the same time of year. September is the best in terms of the least amount of ice, and then of course we can be consistent that way in how we interpret the science by not mixing up seasonality with interannual variability. Okay, next slide. That's all I wanted to say, and I'd be happy to take any questions.
Thanks for that great presentation, Bob. We have questions for Bob?
Yes, this is Renee Tatusco, National Weather Service, Alaska region.
Mm-hmm.
Hi, Bob.
Hi.
First question is, do you know whether or not any of the moorings are capable of transmitting any meteorological information?
Okay, so we don't have a surface expression on these moorings, Renee, because of the fact that we have ice cover during certain times of the year, so we can't have the surface expression. So now ultimately there are things you can do. You can have, for instance, you could try to have a type of mooring that transmits data, measures meteorological parameters, and then when the ice comes, it can somehow react to that, whether it releases an anchor and then floats away with the ice. So there are things you can do to try to address some of those things, but at this moment we're just trying to get a basic set of mooring measurements in the water column on the Russian side in a way that we can keep them going every year and be consistent.
Okay, great. I appreciate that. And then the second question I had, the Russian vessel, do you know whether or not it participates in the WMO volunteer observations from ships, the VOS program?
Gosh, that's a really good question, and I don't know the answer to that, but I'll certainly look into that. That would be a really good thing to have.
Yes, it would.
Yeah.
And I know the Coast Guard is working closely with the Crystal Serenity, and we are working with them to try and deploy a VOS capability as well. And the U.S. Coast Guard has indicated that having those observations is really very beneficial for them.
Yeah, I agree. That's a good question. I'll look into that.
Great. Thanks very much.
Mm-hmm.
I have a question. This is Denny. How do I get a hold of that cool fish book?
Oh, the fish book. You mean the special issue? Is that what you mean? Oh, the fish hook?
No, the book about the Arctic fishes from the RUSALCA trip.
Oh, okay, yeah. So that you mean the special issue? So that's Oceanography Magazine. I'm sure Jeremy can send you a copy of that.
Denny, this is Sandy. I've got a box of about 30 of them outside my office, and I can bring some up to the NSSI meeting.
Yeah, bring a couple along. I know there's a couple of fish geeks that would love to see it.
Will do.
Great, thanks.
Yeah, I've challenged Sandy to get rid of the box of special issues by the end of the summer. So if anybody that wants,
I didn't recall hearing by the end of the summer. I'd be on it by now.
Anyone else with questions for Bob? All right, thank you again, Bob, for a great talk, and we're very excited to see how 2016 plays out with Razalka.
Okay.